Welcome to this lesson on printf. As you've learned, the printf function allows us to display information to the screen. We've used it throughout to display the message "Hello World," for example. In this lesson, you're going to learn how to use printf to display longer character strings, integer values, floating point values, unsigned values, and so we're going to see a myriad of different ways that we can use printf by using Format Specifiers. So let's go ahead and get started. So by now, our Hello World application should look pretty familiar with you. We start with include standard io.h because that's where printf is defined. We've got our int main void, which we typically use, and then we've got our printf message, Hello World. When we run this program, printf displays our message to the screen. A lot of times within our messages, we're going to want to display information on the next line. So we'll display some information, move to the next line, display some more information. And the way we do that is to use the new line character, the /n. And so in our second program, we're separating our messages hello and world using the new line character. And so when we run this program, we see that our output appears on two different lines. We'll typically use the new line character at the end of the statements that we print with printf, so we can advance the carriage return and line feed to the next line. And so early we saw a logic error where our program was successfully compiled but didn't run the way that we wanted to. And so in this case we're using printf. We want to display two messages, each on its own line. But when we run the program, they both appear on one line. That's because we didn't advance the carriage return and line feed to the next line. We can do that, however, just by adding the /n character at the end of our first string. Now when we run the program, we see both character strings on their own line as desired. So the new line character is always going to advance the carriage return and line feed. And so again, this program is going to run correctly. It's going to display this is line 1 on the first line, and this is line 2 on the second line. And it does that by using the new line character. So when we run this program, sure enough, we see our output. So where are we going with printf? We want to be able to display values of integer, float, double, as well as our character strings. And to do that, we need to tell printf what kind of value we want to display. And so in this case, we're declaring several variables: an age, a salary, a weight, a height, a BMI, a body mass index. And so we're going to display those values using printf. And so that first statement, there's a lot going on in that first printf statement. First, we're saying the user's age. Well, the single quote can confuse printf. And so we have to put the slash in front of it when we want to display it. And then we need to tell printf that we're displaying an integer value. That's what the %d does. We're going to look at all these. They're called Format Specifiers in detail. The second line says his salary is, and then we've got a lot going on. We've got our $%8.2f. And the $sign is just going to print as a normal $sign. The %8.2f says, the F says we want to display a floating point value. The 8.2 says the minimum width of this field should be 8 characters. I want to display 2 characters after the decimal point. And then lastly, we're displaying an integer value for weight, an integer value for height, and a floating point value for BMI. Let's go ahead and run this. Don't be too concerned yet with the format specifiers. We're going to look at each one of them in detail. And sure enough, we've managed to combine character strings with integer values, character strings with floating point values, and then a string that had an integer, second integer, and a floating point. And notice that our floating point took up 8 fields, and our BMI value was originally 23.1, and printf just added additional zeros to fill up our field. And so if we only wanted to display the 23.1, we need to tell printf how many characters we want to appear after the decimal point. And we'll learn how to do that. So when we're displaying numeric values with printf, we have to tell printf what kind of value it is. Is it a floating point? Is it an integer? Is it a double? Is it unsigned? And so to display a value of type int, we use the %d format specifier. And so in this program, we're declaring a variable called age, assigning it to value 30, declaring a variable called hours, just assigning it to value 12, minutes, the value 30, and then we printf her age is %d, and we're passing it an integer value. If we had a floating point value, we'd get a syntax error because a floating point value requires a %f. So anytime we want to print an integer value, we use the %d. Notice that we've got the new line character following the %d. That's going to advance the carriage return line feed to the next line. So let's go ahead and run this program. And sure enough, we see her age is 30. The time is 12:30. If we look at our second printf statement where it says the time is, notice how we have a %d, then a colon, and %d. We're separating our hours and minutes with the colon character. And so we're just printing standard characters, but when we use our format specifiers, it tells printf that we're passing a parameter to you of a specific type. Now, depending on our application, when we print an integer value, we may want to print the value in decimal using %d. We may want to present an octal, the base 8 numbering system. To do that, we can use the %o. Or we want to print it in hexadecimal, base 16. We can do that using the %x. So in this case, we're declaring the value 10. And we can present it using decimal, using %d, octal, %o. And then the second line presents it in decimal, followed by hexadecimal. So let's go ahead and run this. And sure enough, we see the value 10 in octal is actually the value 12, and the value 10 in decimal is in hexadecimal, letter A. And so we printed these values out, but it might be nice to tell the user who's seen the output that we're using octal and hexadecimal values. And so we can put a prefix on there, which we'll learn next. So in the previous program, we learned that we can print values in octal or hexadecimal. But when we do that, there's times where we may want to show that it's an actual octal value by preceding the value with a 0, or a hexadecimal value by preceding the value with an x. And so we're doing that in this case within our printf statements. You can see when we get ready to print the octal value, we precede it with a pound sign, and the hexadecimal value in the next line, we're preceding it with a pound sign. When we run this program, printf will precede the octal value with a 0 and the hexadecimal value with a 0x. That tells the user that this is an octal value or a hexadecimal value. When we looked at data types, we learned that an unsigned int value doesn't use the signed bit, but rather it uses it to store the value. And so we've declared an unsigned variable here, RAM, which is a larger value, 65,535. And when we print that, we need to use the %u to tell it that it's an unsigned value. If we use the %d, printf would try to use the sign bit to see is this a positive value or a negative value. And so when we run this program, we see our unsigned value. So the %u specifier says unsigned. Likewise, if we have a long value, we use the %ld. We want to display it as a decimal value, so we have the %d, but it's a long value, so we need to tell printf that, hey, this is a big value. And so we use the %ld. Note when we declare our variable long int det, to tell the compiler that it's a long value, we use the L at the end of the value. And so let's go ahead and run this program. And sure enough, we get our output as desired. Now, a floating point value is a value that has a decimal point. So in this case, we've got income of $150,000, and we have a tax rate of 30%. We want to display those using printf, and to tell it that it's a floating point value, we use the %f, f for floating. And so in this case, we're displaying two values. The first is the income, and then the second is the amount of tax a person's going to have to pay, so the income times the tax. When we run this program, we'll see the following output. So notice the number of zeros that follow the decimal point. Since we're dealing with dollars, we'd really like it to just be 2. And so we'll see how to later format our floating point values to specify the number of digits that follow the decimal point. A character data stores a byte of data, typically an ASCII character. And so in this case, we're declaring a variable grade, that's a character, and we're assigning it the letter A. To print out that value using printf, we use the %char for character. And then we've got the new line character to advance the character return line feed to the next line. When we run this program, we see the following output. So sure enough, it's given us the ASCII character A. So a floating point number is a value with a decimal point. And depending on the value, we may have times that we want to display it as a floating point value using %f, or we may want to display it in exponential format. Let's take a look at an example. We've got a very small number and we've got a very large number. We're going to print both of those using the %e specifier. And so you can see that we've changed that very small value to the value 1.0 by e to the -7. And that's the same representation. And likewise, our large value, we've changed it to 1.2345678 times e to the 9th. And so depending on your values, there may be times that you want to represent it as a floating point or times that you want to use exponential format. To use the exponential format, use the %e format specifier. And so we talked about that when you have a floating point number, it could be very large or very small, and depending on the value, you may want to use the %f to show as a floating point, or %e to show as exponential. Sometimes you won't know the value, and so unless you want to test for it and then use the corresponding format specifier, you can use the %g. And %g tells printf, pick %f or %e depending on the value. Let's go ahead and run this. And so in this case, it displayed the first value as a floating point number and the second value using exponential. So printf made a determination of which would display a more meaningful result to the user. Now through our lessons, we've used printf to display the message hello world, our character string. When we want to print other character strings, we use the %s specifier. So in this program, you can see that we're creating a character string called string. We're initializing it to hello world. Our printf statement says the string is, and then uses the %s specifier followed by the new line character. And then we can do that, and in the second one, we don't have any leading text. We just have the %s specifier followed by the new line character. So we should see hello world printed a couple of times. Let's go ahead and run this program. And sure enough, we see our leading text, the string is %s. And then we just have the %s specifier, print the string only. And so we see both outputs. As you'll learn, a pointer is an address to a memory location. To get the address of a variable, we use the ampersand operator, and we declare the variable as a pointer. And so in this case, we're declaring a variable called a. And we're getting its address and assigning it to a pointer variable called address. We're going to look at pointers in detail, and we'll look at them with character strings, we'll look at them with other values. And so pointers are one of the more challenging concepts of the C programming language, and it takes programmers a little while to get used to them. But as we're looking at them, there's going to be times where we're going to want to print out the corresponding memory address. To do that, we use the %p for pointer format specifier. So let's go ahead and run this program and see the address of A in memory. And sure enough, it shows us a hexadecimal. You can see our 0x tells us this value is in hex. And then we see letters and numbers, which makes sense for hexadecimal output. Depending on your application, you might be creating an accounting application, for example. There may be times where you want to display a value preceded by a plus or minus sign to show whether or not the value is negative. Now, negative values will typically always appear with the negative sign in front of them, but positive values won't. They'll just have the value. And so if you want to force printf to display the plus or minus sign, you can precede the %d format specifier, just put a plus sign before the D as we've done here. And so let's go ahead and run this program. And you can see that it puts the plus sign in front of the 50. Had we left the plus sign out of the format specifier, it would have just shown the value 50. Now, as we're doing formatted output, there's going to be times where we want to display a value, but maybe we want it to take up 5 spaces or 3 spaces. And so, depending on its size, we'll need to pad that output with the proper number of spaces. We can do that in our %d format specifier. So in this case, we're declaring a variable called count. We're going to display it first with one character space. Then we'll do it with 2. If the value is 10, it would display the 0 and 1. If the value is 1, it will display a space in the 1. Then we're going to display it with a %3d that says use 3 spaces. So if the value is 100, it would display the value 100. But if the value is 1, it's going to do a space 1 to get to the 3 spaces. So let's go ahead and look at this output. And sure enough, we see the 1, then a space 1 for the %2d specifier, and then we see a space 1 for the %3d specifier. And so we've learned that we can put spaces in front of our values by using a specifier. And so there may be times where we want to zero pad those numbers instead of using spaces. And to do that, we can use the %0, that says 0 pad. Then we specify the width of the field that we want to display, 1d. The second printf uses %0, that says 0 pad, and use 2 spaces for the value. The third one says %0, 0 padded, 3 spaces. Let's go ahead and run this program and see our output. So you can see that we see the values. In the first case, it was using 1 for %d, and so we didn't need to 0 pad it. The second one, we had 2, we saw the value 1, so we 0 padded it, and then we did 3, and so we had our 2 leading zeros. So when we print floating point values, a lot of times they may represent dollars, or we may only want 1 decimal point or 1 value after the decimal point. And to do that, we need to tell printf how we want it to format the value. So in this case, we're declaring a variable called pi. And in our first printf statement, we only want to show 1 value after the decimal point. The second one's going to display 2 values after the decimal point. The third one's going to display 5 values after the decimal point. The %5 is telling us the width, the minimum width that we want to use for our output. And so if our floating point number is really large, it may be bigger than that width, and it's going to show the entire floating point value. But the %5 and the %5.1 tells us that we want to use at least 5 characters to show this output. Let's take a look at our output as this program runs. And so you can see the leading spaces before the 3.1. That's because we said we want this field to be at least 5 characters wide. Then we have our 2 decimal points, and then we have our 5 decimal points following the value. In a similar way, we can specify the number of decimal points we want printf to use for an exponential number. And so in this case, we're using the 0.123456 as our value, and we're going to print it with just %e. That says, I don't care how many decimal points, printf, you do your thing. The second one says, I want 1 decimal point, or 1 value after the decimal point. The third one says, I want 3, and the fourth one says, I want 5. Let's go ahead and run this and see our output. And sure enough, we're getting our exponential format, and we're controlling the number of digits that appear following the decimal point. So when we specify the width of a field using printf, by default, printf is going to right justify that field. There may be times where we want to left justify our fields, and to do that, we include the minus sign in the format specifier. And so in this case, we've got a variable called year, and we're saying that we want to use a minimum of 5 characters to display this field. And we can left justify it or right justify it. To left justify it, we use the -5d specifier. Let's go ahead and run this output. And sure enough, we see that it's using 5 characters for the fields. In the first case, it's right justified, and in the second case, it's left justified. And so far we've printed either an integer value, a floating point value, an exponential value, or a string. But a lot of times we'll want to print values of all those types using a printf statement. And so we can combine format specifiers within printf to say the first value is going to be an integer, second value is going to be a string, third value is going to be a floating point. So you see we declare the corresponding variables and initialize them. And then within printf we say the item number, which is an integer, is going to be displayed with %d. The description, which is a string, is going to be displayed using %f. And a cost, which is a floating point, is going to be displayed preceded by a $sign with 2 digits to the right of the decimal point. Let's go ahead and run this program. And sure enough, we get our output as we desired. Depending on your program, there may be times when your character strings become really long. And C provides you with a way to wrap that strings, force it to be at the start of the next line, just to kind of format your program a little bit better. And so in this case, we have a character string that we're printing that's a very long string that wraps. And so we use that backward slash to just kind of split our string across 2 lines. And so when we run this program, we see our character string, but within our code, we've better formatted it so it didn't extend all the way across the screen to use multiple lines. So far, you've used the new line character to advance a carriage return line feed to the next line. Turns out that printf supports multiple escape sequences, and so the /a will sound the computer's built-in bell. It's kind of fun to play with. The B will do a backspace. If you're sending output to a printer, you can do a form feed. We've used the new line character. The carriage return by itself, without a new line, will just move the carriage return back to the start of the current line. The /t creates a tab. Again, we could do a vertical tab depending on our device. If we want to print a single quote within a string, we do the /. A lot of times we'll have a character string that has a nested double quote, and that would confuse the string. And so we do the / double quote, a question mark, and then we can do a value in octal or hexadecimal. And so our program uses the first printf statement as asking what's your name, and it's got a single quote in there, so we use the /quote, and it's got a question mark, so we use the /question mark. Our second one is displaying the characters A, B, and C, but it's got the /t to put a tab in between each one of them. And then we start out by saying hello world, but you can see we say hello, then we do a carriage return, which moves the cursor back to the start of the current line and overwrites the word hello with goodbye world. So let's go ahead and run this program and see what our output looks like. And sure enough, there's the single quote that we wanted, the question mark that we wanted, our letters A, B, and C separated by tabs, and our hello world was overwritten by goodbye world. Now when you're printing something complicated, there may be times when you need to know how many characters have I displayed so far. I'm trying to format my screen appropriately. And printf gives us a way to do that using the %n format specifier. It will put the number of characters it's printed so far into the variable that we pass to it. We have to pass the variables by address because they're getting changed within a function. And so in this case, we're declaring 2 variables, A and B. And we're printing the message hello, comma. Then we've got the %n format specifier. That tells printf, assign the number of characters that you've displayed so far, which should be, it looks like 6, to the first variable specified, A. And then print the rest of this. And then %n shows up again, says, well, tell me how many you printed again so far, and assign that to B. And then we're going to display those variables outputs. So let's see what we've got. So sure enough, we see that we've got 6 characters assigned to A and 12, which was the total number of characters that we displayed. You won't use this very often, but if you're doing some formatted output that you need to know where you're at in terms of screen locations, you can use this technique. The printf is a function, and as you'll learn, functions typically return some kind of value, and printf is no exception. It can tell you the number of characters it printed, and it can also tell you whether or not it encountered an error for some reason. And so in this case, we have a variable called count that's being assigned a value returned by printf. It's going to say the number of characters printed were. And we can also check count to see if it's equal to end of file, which printf returns when an error occurs. It's very rare for printf to encounter an error, but we can check for it using the test for end of file. When we run this program, sure enough, we see our hello world message, and the number of characters that were printed is 13. If we count the characters, we'll see that printf was right. So what are we going to learn next? To perform meaningful operations, programs must perform arithmetic operations such as addition, subtraction, multiplication, and division. In the next lesson, we're going to take a look at how to do that within C programs. We'll find that the plus sign is our addition operator, the minus sign is for subtraction, the asterisk is for multiplication, and the slash is for division. So we've got a simple example where we're assigning a variable the value of 1 plus 3. And so we'll look at all of C's operations and operators in detail.